Every one of us, when gazing upward at the deep night sky, experiences a fragment of that same primal awe and profound fascination that accompanied our earliest ancestors. Over the thousands of years of human existence, our collective knowledge of the world surrounding us has grown exponentially. It is an evolution of consciousness that has occurred, from a cosmic perspective, in the mere blink of an eye. Initially, the human mind believed that all of reality was contained within the borders of our planet. Earth was perceived as the absolute center, primary arena upon which the entire drama of existence was played out. It was thought to be surrounded by an unchanging, enigmatic black sphere. But as time marched on, we began to perceive the cosmos as something far greater than just a dark, static firmament. We gradually discarded our mythological veils, and the pioneering telescopes of Galileo and Newton opened vast new horizons before us. We came to understand that we inhabit a truly immense space. Our sense of scale has undergone a series of drastic transformations. The perceived boundary of the world shifted from our planet to our galaxy, which was initially considered to be the entirety of the universe. For decades, the Milky Way, with its hundreds of billions of stars, seemed to be our final and absolute home, a lone bubble of existence suspended in an ocean of eternal darkness. The turning point came when it was revealed that the tiny, faint nebular objects in the sky were not mere clouds of dust, but entire other galaxies. At that moment, we realized just how gargantuan the cosmos truly is. Once again, the boundaries of reality moved significantly further away. Our appetite for knowledge grew with every shift of the horizon, leading us to a fundamental question. It is a question that appears simple, yet represents one of the most formidable challenges of modern physics. Can we reach the edge of the universe and see what lies beyond its borders? Truth we face is exceedingly difficult for the human mind to accept. We are accustomed to a world of three-dimensional boxes with clear walls, but the edge of the universe is an abstract concept that eludes our standard geometric intuition. Space is stretched so far that we do not truly know what lies beyond. To even attempt to understand this mystery, we must first dismantle our everyday perception of totality. We must differentiate between two distinct concepts. This is not a poetic metaphor, but a rigorous requirement of modern astrophysics. We must distinguish between the observable universe and the actual universe as it exists. Our knowledge of the cosmos is inseparably tied to the nature of light, the ultimate cosmic messenger carrying information through the darkness. The universe is approximately 13.8 billion years old. This is a staggering amount of time, yet it is a finite period. Because the speed of light is limited, we can only see a specific bubble around us. Within this bubble, light has had enough time to reach our telescopes. However, we must also account for the constant expansion of space. Because the universe has been stretching during the time light was traveling, current physical radius of our observable universe has expanded to approximately 46.5 billion light-years. This is the extent of the observable universe. If the cosmos were not expanding, this would be the entirety of everything that exists. But we know this is not the case. In the 1920s, Edwin Hubble proved that the cosmos is expanding. This discovery gave birth to a remarkable paradox that scientists grapple with to this day. While the speed of light is the absolute limit for any matter moving through space, the fabric of space itself is not subject to such restrictions. the structure of the vacuum can expand, at speeds far exceeding the speed of light. This means that at sufficiently large distances, two observers would drift apart faster than light, because the space between them is swelling. Nothing moves through the fabric of the universe faster than a photon, but the very floor upon which those photons travel is stretching in an inexorable way. Therefore, the visible universe does indeed have a limit. It is a boundary of approximately 46 billion light-years in any direction, an outline woven from fleeing time and stretching space. But it is not a physical wall. It is not a cliff from which an explorer could fall into a void. If we were able to travel faster than light, we would simply pass more galaxies that are currently invisible from Earth. Those distant systems are moving away so fast that their light will never reach us. This realization only increases the psychological scale of the problem. We want to know where the cosmos truly ends, and what exists beyond those final frontiers. While we cannot know this with absolute certainty, mathematical models and observations of the visible sky have allowed us to develop several fascinating hypotheses. The first possibility leads us into the abyss of infinity. One of the most compelling hypotheses is that of a uniform, an infinite universe. This model offers no final closure. According to this view, one could sail endlessly through the void, passing galaxy after galaxy, without ever encountering a final wall or boundary. In such a vast system, dark energy would drive the expansion in every single point of an unimaginably large matrix. This idea is fascinating, but pure statistics reveal a dark side to this infinite coin. In a universe that is truly infinite, cosmos must eventually exhaust every finite combination of how matter and energy can be arranged. In practical terms, this means that somewhere in the distance, there must be another planet exactly like Earth. There would be people exactly like us, living identical lives, reading these same words. This concept shatters our sense of uniqueness. If there are an infinite number of Earths, then nothing we do is truly singular. Many physicists find the concept of infinity problematic for this very reason, which has led to the proposal of entirely different models. One such alternative was the hypothesis of dark flow. This was not a poetic idea, but an observation of a sudden, unexplained movement of large galaxy clusters in one specific direction. It was as if a massive group of cosmic entities was rushing toward a single edge of the ocean. This led scientists to wonder if something astronomically massive was lurking beyond our visible horizon, an entity with gravity so strong that it could pull millions of suns across incredible distances. However, the nature of science is often brutal toward such ideas. Detailed studies conducted by the Planck satellite showed that this flow was likely an illusion, caused by errors and noise in the background data. The Planck mission, acting with surgical precision, essentially debunked the dark flow. Yet the thought of such a massive, invisible presence hidden just out of sight remains a captivating concept. As we move toward more radical models, we enter realms where gravity becomes extreme. Another hypothesis suggests that our entire universe might actually be located inside a black hole. Imagine a cosmic monster born from a tear in space-time, within an even larger, parent universe. In this scenario, matter and energy falling into that black hole would be crushed to its limits, only to explode on the inside, creating a phenomenon identical to our Big Bang. This would create a fractal-like hierarchy of dimensions, where every black hole in our cosmos could be a gateway to a new universe, with slightly different laws of physics. While the mathematics suggest this could be possible, our observations of reality seem to tell a different story. If we lived inside such a structure, we should eventually see matter pouring in from the outside universe. This would appear as a white hole, a region of space from which matter can only emerge, but nothing can enter. Since we have never witnessed such an event, the black hole universe remains a speculative, though intriguing idea. This brings us to a model that has become a cornerstone of modern theoretical cosmology, the multiverse. This hypothesis is both elegant and reflective of the structures we see in nature every day. It suggests that our reality is just a small, fractional part of a much wider expansion. In this view, multiple universes exist alongside one another, like bubbles in a pot of boiling water. Each bubble could have its own unique set of physical laws. Some might collapse almost immediately after their birth, while others, like ours, endure for billions of years. The reason this hypothesis feels so plausible is that it follows the rule of hierarchical grouping that we see throughout the known cosmos. Planets form solar systems, systems form galaxies, galaxies form clusters. It is only logical to assume that universes themselves might also exist in groups. In this model, the edge is simply the boundary of our particular bubble, beyond which lies a vast, potentially infinite sea of other realities. Finally, geometry and topology offer one last, mind-bending riddle. Mathematics allows us to model a universe that resembles what is called a three-torus. Imagine a three-dimensional donut, where the boundaries are interconnected. In such a universe, space could be topologically flat, yet have no absolute boundaries. If you traveled far enough in a straight line, you would eventually loop back to your starting point, much like an explorer on Earth returns home by sailing around the globe. This would mean we live in a cosmic hall of mirrors. The light from a distant galaxy could travel across the entire universe, loop around, and reach us again. We might be looking at the same distant structures over and over again, perceiving them as different objects, only because of the vast time and distance the light has traveled. Tracing the edge of our cosmic map forces us to constantly redefine what physical existence truly means. The horizon of visibility is an illusion, a protective armor made of light, imposed by the finite speed of electromagnetic waves. Behind that curtain may lie infinite halls of duplicates, vast empty voids, or a bubbling sea of other universes. Our desperate, evolutionary need to understand these unreachable territories proves something profound about our species. Our most important vehicle is not a rocket engine, capable of reaching the speed of light. It is our unyielding desire to cast the light of human intellect into the deepest gloom of the unknown. The abyss of infinity awaits us, and fortunately, we are not afraid to ask the questions.